Welcome to the HVAC-ology experience, where we talk about all things HVAC industry, topics that are so hot, they are cool.
Yeah, let's do it.
Okay. All right. We are in episode 1 of HVAC-ology, and I have with me today Miss Kelly Patterson. Hello, Kelly.
Hello, Brian.
How are you today?
I am fantastic. Really excited to get this podcast started.
I am as well. I've been looking forward to it for some time now. And I'm excited that of all the guests we could possibly have, we have Mr. Brian Keefer. Hello, Brian.
How's it going?
Good. So the goal today, Brian, is for us to talk about just kind of hear your journey of how you got here, maybe like a 5,000-foot view.
Okay.
And then I want to specifically talk about the product of filters, which oddly enough, you took something that was insanely boring to me and you made it very interesting. And just the cost savings that you were able to produce for a customer that we will just call the client here, just for confidentiality reasons. And
Sure.
I'm hoping so that we'll go from your journey to where you're at today, and talk about filters in specific, and then thirdly, kind of end on this client, and then how you took it from what in the world are we going to do to a true success story. Sound good?
Yeah, sounds great.
Cool.
So back up, out of college, business grad, chemistry background, thought I wanted to get into pharmaceutical sales or something in the medical business. My father was in the air conditioning business. He kind of steered me towards looking in that, and I met a guy in Greensboro that got me into doing clean rooms, which were a clean environment with low particles that were pretty popular in the 90s to build out and use for different production area. We did a lot of pharmaceutical. We did a lot of fiber optics were really big back then. So that was kind of a boom back in the 90s. So we were building these little small clean rooms in industrial plants all over the Carolinas and Virginia. And one of the things that were a part of that were filters. And when I wasn't managing projects, he had me talking to people about replacement filter opportunities within all these facilities. So, after you see how things are made 500 different ways from 500 different plants, you start, developing patterns. And that's what you do in filters, right? You realize like, oh, well, if they're doing this process, this filter works well in the combination with this. And it's just kind of like a doctor writing a prescription. At some point, you just say, okay, it's autopilot. I'm going to use this and this when I see this. And through the years, that just sort of developed. The filter business was a lot like the rep business, where you had consolidation and bigger companies buying smaller companies. And so, it's the technology is pretty much the same. They've made a few media advances over the past 20 years, but for the most part, the product's been pretty consistent. I landed at Hoffman. I worked for the guy in Greensboro, and then a bigger company basically hired me to move out of that market and quit competing with them, and they moved me to South Carolina. So that's how I landed in Charleston and started work there. And then same story, met Daryl Frick and found out about Hoffman and all the things it offers, and it was a pretty easy transition. And we didn't do filters at Hoffman back in those days. We just sold them with our equipment and didn't really manage them. And then that was a way for me to keep my relationships with my owners that I had. I want Mr. Owner that you've always worked with for years to start buying equipment from me, but I guess I'll help you with your filter stuff too. And it just sort of turned into a whole separate business within the company, because those guys liked the way we developed the program back in the day.
Mm-hmm.
And that was kind of how it got started.
Very cool. And for those of you listening and you're in Alaska, when he says Charleston, he's saying Charleston, South Carolina. Columbia, South Carolina is where I met Brian Keefer, and then now you are in Wilmington, North Carolina.
That's correct.
Very cool. So kind of take me through, when people think filters, so my background, heavy industrial commercial, but then also owned an HVAC business before coming to Hoffman Mechanical. And the thing that I always found, Brian, is that if there was something wrong with the unit, the first place to look was the filter. And it seemed like people would just let them go so badly. It's crazy to me that one of the simplest things to protect a system is the filter, and it's so ignored. And I've just seen failure after failure because you get that filter, it builds up, right? And once it builds up, that static pressure increases, it kills your fan, it kills your efficiencies, you know. And then also just seeing people being willing to buy that cheap filter, that little, in our industry, they call it hog hair filter or a flat filter.
Yeah.
Kind of take me through the difference between a flat filter and a product that I know that you rep, cam fill filter. Tell me kind of the differences between that.
Okay. So it's funny you mentioned hog hair. I haven't heard that technology in a long time. And a little chemistry behind that. That product used to really be made with hog hair. They would
Huh.
shave the hogs before killing them, and the media manufacturers would buy that, and they would patch it with glue and put dye in it, and it would extrude this like brick of media that had a little bit of opening to it, and people would put it in systems to
Wow.
to clean the air, or humidifiers and something. They had, the properties held up with it. The issue is, of course, it's an animal product, so it would have dander and all the other things that create indoor air quality issues. But that aside, a flat panel, let's just envision, let's pick an arbitrary size like 24 inches by 24 inches, which is a really common commercial size. That's 4 square feet. If you just look at simple physics, the filter gets dirty across the face of 4 square foot of media. And when 4 square foot of media gets dirty, your airflow goes down, time to change filter, or your airflow goes away. So that's a flat panel. The next step from that would be a pleated panel, which kind of breaks into the technology. So the same 24 by 24 filter, instead of 4 square foot of media, you can have almost 17 square foot of media. So now, in theory, you're going to last 4 times as long. Same face, so instead of 4 feet, you're going to get 17 feet dirty, and then you change the filter. Well, the difference in cam fill is the media itself. It's not just a media that is 17 square foot of media like the other guys, but it progressively loads. It's got a more 3-dimensional structure. So think more open to less open to less open. So they use that through a lot different materials. So they'll have blending of fibers. They'll use different types of bonding matrices in their media, dual layers. They've got a couple different technologies, but in theory, it kind of all is the same. But instead of loading 17 square foot of media across the face, you load it across all 3 dimensions like a sponge. And that's why it lasts so much longer. And that filter is a lot more expensive to make, but I've never seen a case where you can't apply it to a building owner and it not save them 30 to 50 to 70% money, depending on how their situation is. And there's guarantees behind it. So it's really risk-free for an owner. And that's one of the reasons that product was so successful for us as a company.
Okay, so if I'm completely ignorant and I'm walking in and I'm seeing MERV 8, MERV 11, MERV 15, HEPA, kind of take me through what that means.
Well, MERV is your minimum efficiency reporting value, and it relates to a particular efficiency of that filter. And there's a chart that's based on fractional efficiencies, E1, et cetera. But it's basically when you test this filter to be in accordance or to be verified as a MERV 8, a MERV 11, 10, whatever, it must maintain efficiency levels across those various spectrums, and you run the filter, you check the box on this level and this level and this level, look at it in your chart. Okay, that's MERV 8. Okay, that's MERV 11. And it's just the higher the number, the more efficient the filter is the most simple way to describe it.
Gotcha.
Are there minimum standards for different industries? Like, for example, hospitals, do they require a different MERV rating?
Yeah. So typically, there's mandates and there's guidelines, Kelly. That's the other thing. There's suggestions and there's laws, and surprisingly, the U.S. is pretty lenient. But typically in a hospital, your pre-filtration is almost always MERV 8 or higher. And then usually, I think with newer standards, it's MERV 15 or higher in a blow-through situation. So in hospitals, everything's got to be filtered after the unit. So that's what we see. You don't see HEPAs everywhere, but we do see those in more critical areas, ORs in some places, cancer treatment, bone marrow transplant, in vitro fertilization, things like that.
What drives me crazy, Brian, is I'll see that, there's a standard of HEPA, and I go and I open the unit, and there's this massive air gap somewhere inside there that's allowing air to just blow by. And, air is going to travel like water, path of least resistance.
That's right. Yeah, and that's real common. And that's one of the things that we do in our office is when we work with owners, if we have an opportunity to look at their systems, we want to evaluate how they are performing. And if you take that scenario, Ryan, your filter will never get dirty. Like, oh man, that thing lasts forever.
Yeah.
And I've seen it. I won't name the hospital. It no longer exists, but I never forget. I was a new employee, and the guy said, "Yep, I've got filters that have been up there 4 years and they last great." I'm like, "Well, have you ever looked at them?" "No." "You want to?" "Sure." We go up, and just like you say, you open up the unit and there's a 2-inch air gap in the wall. And then he pulls one of the filters back, and there's about 10 inches of mold growing out of the back of it with polyps serving an OR area.
Yeah.
And then
Wow.
behind that is a turning vane, which, to steer air. And it's probably a leaf trash bag full of lint, So that's what is in Airstreams if you're not particular about maintenance and following the rules.
So I was at a certain industrial client, and their business was bringing in sugar from South America. And the guy said, "Yeah, ever since I've made some changes to my system, it's been working so much better." And this is on the coast, and this is some nasty air. And we go to look at it, I said, "Well, what changes did you make?" And he says, "Well, I removed that section right there." And it was the filter section. So they've had for years on this product that's been shipping all over the place, air from outside just blowing in there without any kind of
Wow.
filtration. And to your point, that client is no longer in existence anymore. So it's important. Filters are insanely important, from all the way from food quality to operating rooms. And I'm glad that you've taken time to really focus in on that. So, Brian, tell me kind of, if you are not maintaining those filters appropriately, or regularly, as far as what the manufacturer recommends or what your requirements are for your particular need, what happens to that unit if those filters are getting loaded up or getting completely clogged?
Well, a couple of things. For starters, you're not getting the air you're paying for, right? As a building owner, you go through these considerable expenses to build systems that create comfort and or purity for the space that you're providing, and you're not going to get that. You're going to lose the efficiency. You're going to lose the airflow, obviously, and if you don't have filters at all, your very expensive coils become your filter eventually, and they have to be replaced. And it's significantly 100 times more expensive to replace a retrofit a coil than it is to replace a filter. But in general, your maintenance is going to go all to pieces, and then you're going to create building envelope issues because you're passing particulate in the space, and then that gets exposed to environmental conditions, and then that creates more mold. Mold is gold was the old reference in the days from the abatement folks, and they love that, because if the guy's not going to take care of his system, they're going to be a mold abatement client, and those guys are going to just back the truck up. So that's some of the things that I've seen with lack of maintenance on filters.
Yeah, from my side of things, from a service perspective, I've seen it to where, because the airflow gets so low on an extremely cold chilled water coil, that what happens is those coil faces start freezing up, and you have problems with that. And I've also seen, because those fans were not designed for that kind of external static to the system, that they actually end up failing as well. So I mean, it's crazy. It literally can destroy your entire system if those filters
Yes,
are not replaced appropriately.
that's correct.
And is that when you guys get called in, right? Like when a building owner is like, whoa, my HVAC system is just not working at all. Can you come look at it? Or when do you get called in to these jobs?
From my position, yeah. I mean, we've seen it both ways. I would say that the first responder in that would be Ryan's team. You know, the
Yeah.
techs are going to see that call way before we will. But
Mhm.
to fix it, yeah, they're going to call us. You know, to come up with ideas if it's something equipment related that can't be repaired. That's the stuff that we'll get involved with.
Do they ever start noticing it, saying, my electric bills are going through the roof? Do they ever start there, or do they just
No, you'd
wait
think
till the
they
equipment
would.
breaks?
No, it's usually somebody complaining about airflow or not getting enough cooling in a space first. You know, sadly, I don't know. There's a disconnect between expense of equipment and maintenance at times. I don't know that those guys are fully exposed to what it really costs, other than they have an operating budget for filters and whatever. And if they stay under it, they get incentivized by it instead
Right.
of if it's not attached to the building envelope to say, well, I just made a change. I spent, an extra $1,000 a year to make things better for the building and it saves the company 20,000, but I don't see that as a maintenance guy. So that's kind of in there, just industry wide. I don't think
Mhm.
they're aligned in that regard sometimes.
Kelly, you actually said something that was really important right there as well, is that the cost of a dirty filter, how much money that is associated with, because that fan's having to work extra hard. A lot of people don't realize that the most expensive thing to run in an entire building and sometimes facilities, process facilities, is the actual HVAC equipment. And so anything you can do to help that, there's a cost savings that echoes through the entire business.
100%.
Yeah. So, Brian, take me through this client. So, this client calls you up, or you
Yeah.
go and knock on the door of
Right.
them, and they have this massive facility with massive air movement. Kind of walk me through how you help them understand, I
Yeah.
guess, the cost savings associated with that, the payback associated with switching from what they were doing traditionally to the cam fill solution.
Sure. So we had a client that we were partners with already. So we do business with most all big companies in some capacity in our area, and we had some level of trust. So as a courtesy, they offered a meeting for me to come in and just talk to them, and it was a courtesy meeting. I got 10 minutes in a room to tell them my pitch, and when I went in and talked to them, they were using a two-stage system. So they were running a simple pleated disposable filter, not a cam fill product, but just a typical pleated filter, and then a high efficiency 12-inch deep box filter. I think it was MERV 13 or MERV 14 efficiency. I think it was MERV 13 efficiency. They were changing thousands when they needed to change.
Hmm.
And it was a big issue because of power consumption. They're constantly monitoring power because of all the power they're using. And they were having to change pre-filters every 3 months. And they were having to change a V-bank box filter every year and a half to 2 years based on a defined pressure that gave them the lowest operating cost. Um, they had very minimal space, so you can imagine if you bring in 1,000 filters to a location, where you're going to put them because they take up so much space. And not to mention pre-filters, you have to stage them in. And these everything is on the roof. So to try to get up to this facility to do the work, it was a challenge. So you can imagine someone has to get up and crane the materials in, and the safety and the access to the site, and it was just a lot of traffic. They felt they had the best design of a system, and when I looked at it, I felt that they could take two stages of product and use one instead, and they did not believe that would work. And so we had to take a little bit of a risk as a company. But the technology in the material that Camfill offered in this particular product, it was called a high flow ES. It offers a pre-filtration layer built into the box itself or the bag itself. So we were able to convince the owner to let us trial it without a pre-filter and see how the results lasted. Um, the results were tremendous.
Hmm.
So we modeled the system to last 1 year. So from an economic position, if we installed the filter and it lasted 1 year, it really saved the company a lot of money because they eliminated all 3 pre-filter changes. And with the expense of the product, it was slightly less expensive than the box filter. They were able to offset some of the expense of that as well. Plus the labor, plus the energy savings, which was huge. You know, all the spikes of pre-filters getting clean to dirty, clean to dirty, clean to dirty, those top line energy curves, when you're power of the cube with a significant power user, it's a pretty sizable savings. And that was on a 1-year model. Well, once we installed it, we realized the filters are lasting 2 to 3 years.
Wow.
So
Wow.
it became just a no-brainer, and it became a fleet-wide adoption for them. And, you know, now they use them everywhere. And it's been a tremendous product for us. And I think we've saved them. I think we had a roll call not long ago with senior management, and it was the first 5 years we saved them $26 million in energy.
Wow.
Wow.
That's real numbers.
Huge.
26 million
Wow.
and growing.
Huge.
So
Wow.
yeah,
That's
it was a good, you know, it was a good experience for both of us.
And Brian, what they don't even probably realize is opportunity cost, right? So now that maintenance
Right.
guy has the ability to go and do something
Bingo.
else because he's
Bingo.
not changing the filter so often.
Yeah, and we've done some really with our technologies team in the factory at Camfield. We were able to really develop some cool stuff. So we developed a program that lives in their control mechanism, and it predictively measures when the filters are going to load for them. And we've done that with Camfield. They have environmental labs that you can put at a customer's location, like a critical customer location. And they can simulate the filter load that the filter would see. They leave the lab on site, and it's treated just like a regular air conditioning system for the client. And how that filter loads there was consistent with how they load in the data center. So we were able to model that load profile with each site location by geography and predictive how long, okay, this filter's at this. You've got 4 months before you're going to have to change it at your usage rates based off the model, because they vary the airflow up and down all the time. So they know on the performance curve, like, okay, I'm only at 20% of power today, but on the curve, here's what I'm seeing. And I've got, okay, I'm at 60% life on my filter, so I know it's time to plan a change. So we've been able to really help them in their maintenance profiles and get the absolute lowest operating point for them to change per campus. So we think the savings is going to keep going.
So as an aside, after having that conversation with you, I've put nothing but Camfield filters in my house, and
It lasts forever, right?
I totally can tell a difference.
Really?
You don't see the dust, the little it's all kind of like people are putting these air bear cleaners and clean effect. I mean, I'm not going to say names, right? But you can take the brand, whatever, and put it in there. It's all basic stuff. You know, it's not a lot of improvement over what we do.
Right.
It's glorifying something that's pretty common. And honestly, you do a great common product like some of the Camfield offerings, and it does a great job. I mean, and they truly work and truly last. So they're the biggest player by far in the world of air filtration. Not everybody realizes that.
Very cool. Well, Brian, thank you so much for your time and joining Kelly and I on this first inaugural podcast of HVACology. It's been very insightful and helpful, Kelly.
So excited.
Yeah.
Honestly, I learned a lot more about Camfield filters than I knew before this. So I'm pretty excited.
Well, perfect. If you want to keep going anytime, let me know. I've got droves of this stuff. So
I love it.
Yeah, awesome. Thanks for being a part of it.
Yeah,
Absolutely.
well, thank you, Brian. And Kelly, enjoyed hosting with you today and look forward to future episodes.
Me too. It's going to be a great time.
With that,
Thanks,
thank you
guys.
everyone for listening in.
All right.
Rocket past Saturn, things don't seem to matter much to me. anymore. Got lost inside a daydream, get sick of all schemes they play on their machines. I lost so many words as I got older. You would have thought I would have stored them in my Manila folder. Accidentally wrote these words down, thought all the best of me faded in an endless sea. But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside? But you always bring me back at your blue eyes. 20 years of staring at that freckle on your left shoulder. Who would have thought all I needed was to think of you to bring back the words inside of me? I drove an hour to see you. Things just seem to matter more to me anyway. Got lost in reality, no answers to cancer, we never got to talk. Lost so many friends as I got older.